Class, today we're going to go over chapter 5, and this chapter specifically focuses on electrons in atoms. In section 1, we're going to talk about revising the atomic model that we left off on talking about in chapter 4. If you remember, we left off on Ernest Rutherford's gold foil experiment, and he proposed the following about an atom. First, he said that protons and neutrons make up the nucleus, which is located in the center of the atom. And remember, the nucleus is pretty dense and is also positively charged. Second, he said that electrons were located in the space outside of the nucleus. So there's really no fixed area where they're located, they're just out there somewhere. Now, this is awesome because it did explain some of the properties we saw in atoms, but it had a limitation because it could not explain all the things we saw. For example, it could not explain certain chemical properties of elements. Your book specifically states it could not explain why things like metal or compounds that had metals in it gave off characteristic colors whenever they were heated in a flame. This is a picture of an iron scroll. Here is the typical color of iron, but as you heat it up, it will change colors. It will go from a orange to a yellow, and then at very high temperatures, it has an almost white appearance. So explaining what led to this color change when you heat iron or other chemical properties of elements required a different model, and this model needed to describe the behavior of electrons. The reason for this is because electrons determine chemical properties of elements. Rutherford's model was actually replaced by a scientist called Niels Bohr. He was a young Danish physicist and actually a student of Rutherford's, and he developed a new atomic model called the Bohr model. What he did was he took Rutherford's model and incorporated new discoveries that had been made during his lifetime. And specifically, he related how the energy within an atom can change whenever an atom either absorbs light or emits or gives off light. So our key question, and we're going to state specifically, what did Bohr propose in his model? Bohr proposed that an electron is found only in specific circular paths. We call these circular paths orbits. They kind of orbit around the nucleus, kind of like planets orbit around the sun. So here we have one circular path, two circular paths, three. Now, each of these orbits or circular paths had a fixed amount of energy. And we called these fixed energies energy levels. So the first orbit would be energy level 1, the second one would be energy level 2, followed by energy level 3. Now, one thing about energy levels is this is where you typically find an electron. But an electron is not going to stay in the energy level that it's in. It can actually move up an energy level or down an energy level depending on if it got energy. A quantum of energy is actually defined as the amount of energy needed to move an electron from one energy level to another. So if an electron or atom got enough energy, it could move up energy levels. Now, each energy level can only hold a maximum number of electrons. So, for example, that first energy level can only hold 2 electrons in that inner ring. The second energy level can hold a max of 8. The third one can hold 18, and the fourth one can hold up to 32. So this is a picture of my energy levels. That's why you see a 2 here, 8, 18, and 32. Now, the periodic table symbol, if you look at it, can actually tell you the number of electrons in each energy level. I took this snippet out of the periodic table I have on my website, And it tells you it right down here on the bottom, called an electron configuration. Carbon has 6 total electrons in it, because in a typical atom, protons equal electrons. So if my atomic number is 6, my electrons also must be 6. It has 2 electrons in the first energy level and 4 electrons in the second. Even if we look at other elements, such as germanium, it has 2 electrons in the first one, 8 electrons in the second energy level, 18 in the third, and then 4 electrons in that last energy level, or the fourth energy level. Let's talk about the Bohr model a little bit more in detail. Here I have a picture of a ladder, and it says the rungs on a ladder are somewhat like the energy levels in a Bohr's model. A person on a ladder cannot stand between the rungs. You either have to stand on this rung or this one. Similarly, electrons cannot exist between energy levels. It either has to be energy level 1, 2, 3. It can't be 1.5. However, it is a little bit different because the rungs on a ladder are evenly spaced, but energy levels aren't equally spaced. So if you were to correctly draw what an energy level would look like on an atom, you would have from the first rung to the second rung, it's a big gap. And then as you got higher, it made smaller and smaller and smaller gaps. So the higher the energy level, the closer those energy levels are to one another. Basically, the reason for this is it actually takes less energy to climb from one rung to another near the top of the ladder. And so it's just like an electron and its energy levels, less energy is needed to move to a higher energy level the farther away you get from the nucleus. And the reason for that is because the nucleus is positively charged. So the farther an electron gets from that proton, the less it's going to be attracted to stay near, and it doesn't need as much energy to pull it apart. So an electron in an atom can actually move from one energy level to another, and I've hinted at this, and it does this whenever it gains or loses energy. Here I have an example of an atom. I have my nucleus and my electron on my first ring, or my first energy level. If energy comes in, so this is a photon, which is energy. If it comes in and the electron absorbs it, this electron can actually move up to the second energy level and be excited. So here, energy can be absorbed and it can go up, or energy can be released and it can come down energy levels. Now, an electron may move up or down 2 or more energy levels if it gains or loses the right amount of energy. So essentially, the size of the jump between energy levels is going to be determined by how much energy did it gain. Did it gain a lot of energy or just a little bit? Now, this movement of electrons between energy levels is a perfect explanation of why we see different colors of light when we look at fireworks or when an iron scroll is heated. What happens are electrons usually gain energy, and it does this usually in the form of heat. So if you heat something up or a firework explodes, this heat or energy is taken in by an electron, and these electrons move to a higher energy level. Now, those electrons can't stay at that high energy level forever, so eventually those electrons is going to release that energy, and when they release that energy, they release it as visible light that we are able to see. Now, different elements are going to emit different colors of light depending on how much energy they lost. So certain energy amounts allow us to see different colors of light. So how did Bohr's model improve upon Rutherford's model? The Rutherford model could not explain why elements that have been heated can give off different colors of light, but Bohr's model explains this using the concept of energy levels, It states that because of energy levels and electrons moving between them, that's why we see these different colors, or this is why we see light being emitted. So in today's homework, we're going to learn how to draw a Bohr model of an atom. We can actually accurately depict the Bohr model for the first 18 elements on the periodic table. Now remember, the first energy level can only hold 2 electrons, the second can hold 8, and the third can hold 18, and so on. So here are the steps to do this. First, you want to place electrons in each energy level as a dot. Second, you want to fill each energy level first before moving on to the next. So here, this is energy level 1. That's why you see 2 electrons here. Once you fill those 2 electrons, the first energy level can't hold any more. So you have to go to the second energy level, which can hold 8. Now, over here I said add 1 electron at a time. So you would add 1 electron, 2 electron on the right, 1 on the one on the right, 1 on the bottom, and 1 on the left. And if you had any more, then you would pair them up going around again. So that's why on the outside you see these being paired and then 1 on each side. This is an example of phosphorus, which has 15 protons and 15 electrons. Note, electrons located in the highest energy level, which is your outermost ring, are called valence electrons. And valence electrons determine chemical properties of elements. So here, phosphorus has 1, 2, 3, 4, 5 valence electrons. Now, before I finish out, I just want to explain one last thing to make sure you guys completely understand. The reason we have phosphorus as having 15 dots here is because it has 15 electrons. We know this because it has 15 protons. And again, we know that it has 15 protons from the atomic number of phosphorus. This brings back chapter 4. So make sure that you completely understand that. And if you have questions, make sure you guys come up and ask. And otherwise, that's the end of today's lesson. And I hope you guys have a great day.